Hello, this is Mrs. Ross, and this is 4.4 Complex Zeros of Polynomial Functions. Just a reminder, the fundamental theorem of algebra says that the number of zeros is equal to its degree. For example, this polynomial has a degree of 3, so there's 3 zeros. To find the zeros, they want us to use the rational zero theorem. That's where we divide P and Q. We come up with all of these different roots, synthetic division, etc., etc. So let's see if we can get this did. So if we flip to the now you try, it says how many zeros does this have? Well, I know that there are 4 total zeros because it's a degree of 4. Use the rational zero theorem and a graph of the function in synthetic division to confirm your answer. So rational zero theorem. In the rational zero theorem, A0 is 1 and A4 is 4. So we have the roots of 1 are 1 and the factors of 1, and then the factors of 4 are here. This is P, this is Q. So P over Q is, let's see, 1 over 1, 1 over 4, 1 over 2. So we have 1 over 1, which is 1, 1/2, and 1 over 4. That's it. So it's going to be plus or minus 1, 1/2, or 1/4. So then, so this is going to be step 1. I'm going to grab a different color. Maybe I'll do orange so we can do rainbow. Step 2 is going to be to graph it. And if you graph this in Desmos, you'll find that there are zeros at -1, -1/2, 1/2, and 1. Okay, I just stuck with this. I want to put a little disclaimer in here. I did not confirm these zeros with synthetic division because there's 4 of them, and frankly, So, all right, conjugate zero theorem. So what are the possible zeros of the function that? So I know that there's going to be 5. There's 5 total zeros. Okay, we know that from the fundamental theorem of algebra, which was on the last page, I think. Now here's what we did not know, or maybe we did, IDK, that the conjugate zero theorem tells us that complex zeros occur in pairs. Okay, that's the conjugate theorem. Conjugate zeros theorem. Man, okay, the writing is not writing. So I can either have 5 real zeros, I can have 3 real zeros, and 2 complex, because they have to come in 2s, or I can have 1 real zero and 4 complex. Okay, these are my options here. Okay. Example, suppose a 5th degree function has zeros that, and that. What are the other zeros of the function? So if it's a 5th degree function, I know that it has to have 5, right? So we already know this one, and this one. I'm going to take the conjugate of this one, and that would be another one of the, man, I am not writing right. And then also the opposite of this one, so because of the square root. So that should be all 5. Okay, flip the page. Find the zeros of this one. Flipping the page. Oh boy, lots of writing on this page. Let's go. Okay. So the first thing we're going to do is we're going to graph this. And if you graph this, you will find that there is a 0 at 5, 0, and -2, 0. Wonderful. Then I'm going to do synthetic division. And I'm just picking 5. So we have 1, -3, 8, -54, -180. So I'm going to do some synthetic division. Bring my 1 down. 5 times 1 is 5. -3 plus 5 is 2. 5 times 2 is 10. 8 plus 10 is 18. 5 times 18 is 90. -54 plus 90 is 36. 5 times 36 is 180. And that gives us a remainder of 0. So I have a root that is 5. Then I'm going to take the -2, and I'm going to divide it into this. So we have 1, 2, 18, 36. So I drop the 1 down. -2 times 1 is -2. 2 plus -2 is 0. -2 times 0 is 0. 18 plus that is 18. -2 times 18 is 36. -36, that's 0. Okay, so both of those are roots. This ends up being x. Oh, we did that. Let's erase that. 10. X minus 5 times, let's see, this is x cubed minus 2x squared. Oh wait, plus 2x squared plus 18x plus 36. And then when I come down here, I get x minus 5, x plus 2 times x squared plus 18. Okay. Then I have to do quadratic here. Quadratic. I need a new, anyway, it doesn't matter. So let's see. So we've got x is equal to -b plus or minus square root of b squared minus 4ac over 2a. So let's plug that in. B is nothing. B is 0. Plus or minus square root of 0 minus 4 times 1 times 18 over 2 times 1. Okay, I'm going to erase some of this so that we can get all of this done. Okay, let's bring this up here. So we have, let's see, the square root of -72 over 2, which is going to give us, so if I prime factor this, I'm going to get 2, 36, 6, 6, 2, 3, 2, 3. If I have 2 in the house, I can take it out. So that gives me plus or minus 6 square root of 2i over 2. These are going to cancel. Plus or minus 3 square root of 2i. Okie dokie. So my zeros are 5, -2, 3 square root 2i, -3 square root 2i. Delightful. And there's just more like that, honestly. Let's change colors. Okay. Now you try. What are the possible types of zeros? So this is going to have 4 total zeros. It's either going to have 4 real zeros. It's going to have 2 real and 2 complex, or it's going to have 4 complex zeros. Let's see, suppose a 5th degree polynomial has, let's see, -6, 9 minus 5i, and -7 plus 11i. These are 3, we need 2 more. So we need the conjugate of this one, which is 9 plus 5i, and of this one, -7 minus 11i. Okay, find all the zeros. Oh, Oh, this one's a long one. Okay, so the first thing we do is graph to see if we can figure out what the zeros might be. And it crosses at 3. So then I did synthetic division. So I have 3, 2, negative 7, 27. Why did I put a plus there? I do not know. It doesn't need to be a plus there. There we go. So 3 times 2 is 6. That's negative 1. 3 times negative 1 is negative 3. That's 24. 3 times 24 is 72. Negative 84 plus 72 gives me negative 12, which gives me negative 36, which gives me 0. So 3 is definitely a root. I don't want to do that. So we are just going to, I'm sorry, I did the rational zero theorem and it got crazy. So we're not going to deal with that. But what's awful is the next one we're going to do is divide by 1/2. Seriously though, bro? Why? Oh, it's like the definition of a try-hard. Good grief. Okay, so 2 gets dropped. 1/2, like the 1/2 times 2 is 1. That's 0. That's 0, 24. That's going to be 12, and it works out. You think it's going to be awful, but it's not. So, anywho. So up here, we have x minus, let go, minus 3. Oh, 2x. Okay, and then we took this down here, so now we have x minus 3, x minus 1/2, because we know that that works, and we're left with 2x squared plus 24. Guess what we get to do? Quadratic. Gosh, we're never going to escape the vertex that is. Pre-cal. Okay. It has an end, I promise. 0 plus minus 0 minus 4 times 2 times 24. 2 times 2. Okay, keep going. Here we go. So I get plus or minus the square root of negative 192 over 4. So what I did, I'm going to change colors because I can't anymore with this one. So what I did was I prime factored this one. This is 248. This is 6, 8. This is 2, 3. This is 2, 4, which is 2, 2. Okay, great. Lovely. Plus or minus. And then, let's see, if there's 2 in the house, I can take 1 out. So there's 2. There's 2, so that's 4. There's 2. So that's 8. So I have 8 square root 3's left inside over 4. This is going to become plus or minus 2 square root of 3. I. I. So our zeros are 3, 1/2, 2 square root of 3i, negative 2 square root of 3i. Yay, we did it. Okay, let's see. I'm going to stop the video here and make a part 2 because there's more.